On July 6, 1936, a thermometer in Steele, North Dakota, reached 121 degrees. That is still the hottest reading ever taken in the state, and it was only the opening of the summer. Over the following weeks, the heat spread across the middle of the country, brushed the Atlantic coast and settled back over the plains. By the time it lifted, about 5,000 people in the United States were dead from it. No American heatwave in the records has killed more. If you find these reports useful, you're welcome to subscribe. What makes this one worth a closer look is where the heat came from. The land itself had been stripped bare by 3 years of drought and hard ploughing, and bare, dry ground heats far faster than moist ground under cover. The Dust Bowl helped build the oven it then baked in. This report walks through all of it. The record cold winter that came first, the week the heat locked in place, the nights that never cooled, the farms that failed, and the count of the dead, which is still an estimate. The heat that killed 5,000 people began, oddly enough, in a country that had just finished freezing. The winter before was one of the worst the northern states had ever recorded. Across the lower 48, February of that year came in as the coldest February ever measured, with a nationwide average near 25 degrees. In the northern plains, it was far worse than that number suggests. A thermometer at Partial in North Dakota fell to 60 degrees below zero, and that reading still stands as the coldest the state has ever seen. At Langdon, near the Canadian line, the temperature stayed below zero for 41 days without a break, counting the afternoons as well as the nights. At Turtle Lake, the average temperature for the entire month worked out to about 19 degrees below zero, which remains the coldest monthly average ever recorded anywhere in the contiguous United States. Those numbers are not decoration. They tell you what kind of air mass had been sitting over the middle of the continent, and they tell you how completely that pattern would have to change for what came next. Partial and Steele sit about 110 miles apart. In February, one of them recorded 60 below. In July, the other recorded 121 above. Between those two readings lies a swing of 181 degrees, taken in the same state, in the same year, by the same weather service. Nothing in the American record comes close to that. People at the time noticed the whiplash, and they mostly noticed it as hardship stacked on hardship. This was the middle of the Great Depression. Farm families in the Dakotas and Minnesota and Montana had spent the winter burning corn cobs and cow chips because coal cost money they no longer had. Livestock froze in the barns. Rural roads closed for weeks at a stretch. Trains ran late or not at all. When the thaw finally came in March, it came fast, and the ground took the water the way a paved lot takes rain, because the soil beneath the frost was already dry from 3 years of drought. That last point matters more than it looks. Snowmelt in a normal year soaks in slowly and recharges the topsoil, and that stored moisture carries a field through June. In the spring of that year, much of the melt ran off, and much of what soaked in was gone by early summer, because the subsoil below had nothing left to hold it up. The land entered June with almost no water in the bank. There is a habit of thinking about record cold and record heat as opposites, as if one balances the other. In the physical world they can share a cause. Both extremes depend on a jet stream that has stopped behaving like a smooth river and started buckling into deep loops. When the loop dips south in winter, Arctic air pours down the middle of the country and stays. When the loop bulges north in summer, warm air piles up under it and stays. The same stubbornness produced both readings. It is one of the reasons that year appears at the top and the bottom of so many record lists at once. By the time the cold broke, the Weather Bureau had a country that was dry, broke, and already exhausted. The dust storms of the previous years had scoured parts of Kansas, Oklahoma, Colorado, and the Texas Panhandle down to hardpan. Farms across the plains had been abandoned. The people who stayed were living close to the margin, in houses built to hold heat in winter, with roofs of tar and walls of brick, in cities where a family of 6 might share 3 rooms and 1 window. What none of them had was any warning system worth the name. The Weather Bureau issued forecasts and newspapers printed them, and radio stations read them aloud. There were no heat advisories. There were no cooling centres. There was no public health guidance about drinking water or checking on elderly neighbours, because the science that produced that guidance had not been written yet. Heat was understood as discomfort. It was not yet understood as a killer that works quietly, indoors, over several days. So the country went into that summer with dry ground, hot air on the way, and no idea what was coming. The cold winter is not the cause of what followed. It is the proof of how far the atmosphere over North America had swung and how little cushion the land had left. The heat needed one more thing to become historic, and it was already in place, spread across 1,000 miles of ploughed and blowing dirt. Rain is what keeps a landscape cool. That sounds obvious, and the mechanism behind it is worth a moment, because it explains almost everything about the summer that followed. When sunlight strikes moist soil or a field of growing wheat, much of that energy goes into turning water into vapour. Water takes an enormous amount of energy to evaporate, and while it is doing that, it is not raising the temperature of anything. The heat goes into the change of state instead. A wet field spends the afternoon quietly steaming, and the air above it warms only a little. Farmers have always known the practical version of this. Walk from a bare gravel lot into a green cornfield on a hot afternoon, and you can feel the difference on your skin. Now take the water away. Sunlight still arrives at the same rate. With no moisture to evaporate, nearly all of that energy goes straight into heating the soil surface, and the soil heats the air directly above it. Temperatures climb faster, higher, and later into the evening. The land stops behaving like a garden and starts behaving like a stovetop. By the summer of that year, an enormous share of the American middle had been turned into stovetop. The drought was in its third year. It had started across the plains, spread east into the Corn Belt and settled in. Rainfall over the contiguous United States that summer would finish as the second lowest ever recorded, averaging just over 6 inches for the whole season. In Wisconsin, July brought less than 1 inch of rain statewide, the driest July the state has on record. By the middle of August, some Wisconsin farms were running a rainfall deficit of a foot. Drought alone would have been bad. What made it worse was what people had done to the ground beforehand. Through the 1910s and 20s, tractors and grain prices had pushed farmers to break millions of acres of native prairie across the plains. That prairie sod had been the product of thousands of years, a dense mat of deep roots that held soil in place, held water like a sponge, and kept a living cover over the dirt through the hottest months. Ploughed under and planted to wheat, it produced good crops in wet years. In dry years, when the wheat failed and the fields lay bare, there was nothing left holding anything down. The result is the thing everyone remembers: the black blizzards, the dust piled against fence lines, the photographs of farmhouses half buried. What is less remembered is that dust storms and heat waves are the same story told at different speeds. The stripped dry ground that let the soil blow away in spring is the stripped dry ground that superheated the air in July. Meteorologists who have looked at that summer since have described a feedback that fed on itself. Dry soil produces hotter air. Hotter air pulls the last moisture out of whatever soil is left, and out of any plant still trying to grow. Hotter, drier air also resists forming clouds and thunderstorms, because rising air needs moisture to condense and release energy. The thunderstorms that would normally cool an afternoon on the plains simply stopped forming. Each day without rain made the next day more likely to be hot, and each hot day made rain a little less likely. Once that loop is running, it does not need much help to keep going. It needs a weather pattern that holds still. Farmers described the ground itself as strange that summer. Corn curled and browned in early July, weeks before it should have tasseled. Pastures went the colour of straw. Wells that had served 4 generations came up dry. In Missouri, farmers were paying the city waterworks by the 1,000 gallons to keep animals alive, and hauling it home in tanks. Small streams stopped flowing altogether, and the shallow ponds that livestock drank from turned to cracked mud. There is a temptation to describe this as the land being punished. It is more accurate and more useful to say the land had lost the one thing that regulates temperature. Water in the soil is the reason a July afternoon in Iowa is uncomfortable rather than lethal. Take it away across half a continent, and the ceiling on how hot the air can get rises with it. The stove was hot. It still needed a lid. The first hint of what was coming arrived in early June, and almost nobody paid attention to it because it lasted 3 days and then went away. Over the opening days of the month, warm air pushed into the northeast. Allentown in Pennsylvania hit 95 degrees, about 20 degrees above what that town expects at that time of year. New York City reached 90. Baltimore reached 96, just short of a daily record that had stood for 11 years. Newspapers ran the usual photographs of children in fountains. Then the pattern relaxed, temperatures fell back to normal, and the story vanished. Warmth was building in 2 other places at the same time, and those 2 places mattered more. One centre of heat sat over the southeast. The other sat over the Rocky Mountains and the Western Plains. Neither looked remarkable by itself. Both were symptoms of the same thing, which was a jet stream that had begun to bulge northward and leave big pools of warm air behind it. Through the second half of June, the southern node grew teeth. In the space of about 10 days, a run of states set monthly heat records that had never been touched before, and in some cases have not been touched since. At Corning, in Arkansas, the thermometer reached 113 degrees. At Dodson, in Louisiana, it reached 110. Greenwood, in Mississippi, reached 111. Doniphan, in Missouri, reached 112. All of those readings came within a day of each other, and every one of them was the hottest that state had ever recorded in the month of June. The heat then leaned north. Franklin, in Nebraska, reached 114. Toward the end of the month, St. John, in Kentucky, and Etowah, in Tennessee, both hit 110, and Seymour, in Indiana, hit 111. Those were June records for 3 more states. Shreveport reached 104, Little Rock reached 105, Memphis reached 103. St. Louis and Kansas City both set daily marks. Stack those readings on a map and a shape appears, a wide band of extreme heat, running from the lower Mississippi Valley up through the Ohio Valley and out onto the Central Plains, in the last week of what is supposed to be a mild month. June is not when the American interior peaks. July and August are. The atmosphere was already producing August in June, over ground that had been drying for 3 years. Local reaction was muted, which is easy to understand. Hot spells happen. The Depression was in its 7th year, and a farm family reading about a record in Arkansas had more pressing concerns. What no one could see was the atmospheric structure taking shape overhead, the way the 2 warm nodes were beginning to merge and organize. Weather forecasting at the time worked mostly from surface maps. Observers around the country reported pressure, temperature, wind, and cloud by telegraph, and the Weather Bureau drew those observations onto a chart twice a day. Forecasters read the chart, compared it with yesterday's, and projected the systems forward by eye and by experience. It was skilled work. It was also, by necessity, short range. Nobody was analysing the upper atmosphere in any systematic way, because the instruments that would routinely sample it were still years from full deployment. A forecaster could see a high-pressure area on the map. He could not see the enormous dome of warm air sitting above it, and he had no reliable way to know how long it would sit there. So the forecast said hot and dry, and they said it again the next day, and the day after. They were correct. They simply could not say how long the answer would keep being the same. By the last days of June, the 2 warm centres had begun to consolidate over the middle of the country. The pattern that had been loose and shifting was settling into something rigid. The jet stream that steers cool fronts across the northern states had lifted well up into Canada, and the storms that ride it went with it, passing harmlessly north of Montana and North Dakota. Underneath, the air had nowhere to go but down, and down is where air gets hot. A high-pressure system is simply a place where the atmosphere is heavier than its surroundings, and where air is slowly sinking toward the ground. That sinking is the engine of everything that followed. Air that descends gets compressed, because the pressure around it increases as it drops. Compress a gas and it warms. Anyone who has pumped a bicycle tyre and felt the pump grow hot in their hand has met the same principle. The atmosphere does this on a scale of miles rather than inches. A parcel of air sinking a few thousand feet can warm by many degrees before it ever touches the surface, and it arrives dry, because sinking air pulls moisture away from itself rather than condensing it. That is why fair weather sits under high pressure. Sinking air kills clouds. It flattens the rising thermals that build afternoon thunderstorms. It clears the sky, and a clear sky lets the sun work on the ground without interruption from dawn to dusk. Now hold that system in place for weeks instead of days, and stretch it across most of a continent, and you have what modern forecasters call a heat dome. The surface maps from the early days of July show the arrangement clearly. One large area of high pressure sat over the Appalachian Mountains in the southeast. Another sat over Oregon and Washington in the northwest. Between and above them, the jet stream had been forced far north into Canada, taking the storm track with it. The whole middle of the country lay beneath a bulge of warm air with nothing to break it apart. Within a week, the western high drifted southward over Colorado, which reinforced the dome rather than weakening it, and locked the pattern in. Picture a lid on a simmering pot. The lid does not add heat. It prevents the heat from escaping, and it keeps the steam from rising and carrying energy away. That is roughly what the dome did to the American interior for the better part of a month. Two things then happened at once, and they reinforced each other. The sinking air warmed by compression, day after day, with each day starting from the elevated temperature the last one had produced. Nights were too short and too warm to reset it, and the sunlight coming through that cloudless sky landed on ground with no moisture to spend. So all of it went into heating the surface and the air just above. The land and the sky were feeding the same fire from opposite ends. Winds around a northern hemisphere high-pressure system circulate clockwise. That detail decided who suffered most. With the dome centered over the central and northern plains, the flow on its western side pulled hot, dry air up out of the southwest, and the high plains and drove it north and northeast, straight over Kansas, Nebraska, the Dakotas, Minnesota, and Wisconsin. Air that had already been baked over bare ground in Colorado arrived over the upper Midwest with almost no water in it, and the sun went to work on it again. Modern research has a name for the temperature that results when you superheat dry air over dry ground and give it nowhere to go. Forecasters watch for it every summer now, and the tools they use include satellite measurements of soil moisture, because they have learned that the state of the ground in June tells you a great deal about the ceiling on temperatures in July. None of those tools existed then. What existed was a Weather Bureau observer at a small station somewhere on the plains, reading a thermometer inside a white louvered box on a post, twice a day, and writing the number in a ledger. Over the first week of the month, those ledgers began filling with numbers no observer had seen before. The dome had settled. The ground was ready. What arrived next was not weather in the ordinary sense. It was the highest temperature anyone in that part of the country would ever write down. Steele, North Dakota, is a small town on the flat ground east of Bismarck, in a county where the land runs to wheat and grass and very little shade. On the day the record fell, the observer there read 121 degrees. That number deserves to be held still for a moment. 121 degrees is a Death Valley number. It is hotter than Phoenix has ever been. It was recorded in a state that shares a border with Canada, in a place where the ground stays frozen well into spring, by a man standing in a wheat field. It remains the highest temperature ever officially recorded in North Dakota, 90 years on, and no reading since has come within several degrees of it. The same day, at Moorhead, on Minnesota's western edge along the Red River, the thermometer reached 114 degrees. That too still stands as the Minnesota state record. Both readings come from the standard practice of the time. The Weather Bureau housed its thermometers in white wooden shelters with louvered sides, mounted a few feet off the ground in the open, away from buildings. The design was meant to shield the instrument from direct sun while letting air move through freely. Modern climatologists have gone back through the observations from that summer with real care, checking sighting and instrument history, because extreme records invite scrutiny. The North Dakota and Minnesota readings have survived that scrutiny. They are treated as confirmed. What they describe is an air mass that had run out of any mechanism to cool itself. Along the Red River Valley that afternoon, the humidity was low enough that the heat did not feel the way heat feels in Houston. It felt like standing in front of an open oven. Farmers reported that the wind, which normally brings relief, made things worse because it was hotter than skin. Wet a cloth, and it dried in your hand. Livestock crowded into whatever shade a windbreak offered, and animals that could not find shade died where they stood. Both of those record readings sit in country where almost nobody lived. Steele had a few hundred residents. The great mass of Americans who would die that summer lived hundreds of miles east, in Chicago and Detroit and St. Louis and Cleveland, and their temperatures never reached 120. This is a pattern that repeats in every heatwave since, and it is one of the most useful things to carry out of this story. The place with the highest number on the map is almost never the place with the highest death toll. Death from heat depends on how long the heat lasts, how warm the nights stay, how old and how poor the population is, and whether a body has anywhere to go to shed its own warmth. A farmhand in North Dakota at 121 degrees in dry air, drinking water and working through the morning and resting in shade at noon has a fighting chance. A 70-year-old widow on the top floor of a Detroit brick walk-up at 104 degrees, with a window facing an alley and no fan, over 6 consecutive days and 5 consecutive nights does not. The plains readings did tell the country something, though, and the newspapers understood it immediately. This was not an ordinary hot spell. Records were not being broken by a degree. They were being broken by 3 degrees, by 5 degrees, by 6 degrees, at station after station across 1,000 miles. When a record that has stood for 40 years falls by half a degree, that is weather. When a dozen records fall by 5 degrees each in the same week, the atmosphere is doing something it has not done before within living memory. The dome held. On its eastern flank, the clockwise circulation began to push that superheated air toward the Great Lakes, and beyond the Great Lakes toward the Ohio Valley, the Appalachians and the Atlantic coast, where 2/3 of the country's people lived in cities of brick and stone. The heat was about to leave the empty places and arrive where the crowds were. Within 2 days, the leading edge of that air had crossed the Mississippi and was moving over the industrial Midwest. Flint, Michigan, reached 108 degrees. South Bend, Indiana, reached 106, its second straight day above the century mark. Indianapolis and Fort Wayne both reached 104. Louisville reached 103. These are not desert towns. They are places where a 95-degree afternoon is considered a bad summer day, and they were running 10 degrees past that. Then the dome shifted just enough to swing the hot air over the Appalachians, and for about 72 hours the eastern seaboard experienced something it had never experienced before and has not experienced since. Nearly every all-time maximum temperature record from Virginia to New York fell. At Phoenixville, in Pennsylvania, the thermometer reached 111 degrees. It stands today as the Pennsylvania state record. At Runyon, in New Jersey, 110, which stands as the New Jersey record. At Martinsburg, in West Virginia, 112, still that state's highest. Cumberland and Frederick in Maryland both reached 109, and both still share the Maryland record. New York City hit 106 degrees. Consider what that meant in practice. New York in that era was a city of tenements, 6 stories of brick with air shafts instead of windows on the interior rooms. Cooling, for most people, meant opening a window onto air that was hotter than the room. Reporters at the time described tens of thousands of New Yorkers dragging mattresses onto rooftops, out onto fire escapes, and down to the docks and the parks, sleeping in the open because their apartments had become dangerous. Newspapers carried accounts of factory workers collapsing at their stations, including a report from one garment shop where 75 seamstresses went down in a single day. Those figures come from press accounts of the time rather than from any official tally, and they should be read that way. But the pattern behind them is consistent across every city the heat touched. Cities amplify heat, and they do it for reasons that are physical rather than metaphorical. Brick, asphalt and stone absorb solar energy all day and release it slowly all night. A city block with no trees and no soil has no water to evaporate, which means it behaves exactly the way the parched plains behaved, only with millions of people living on top of it. Scientists now call this the urban heat island, and they measure it routinely. The core of a large city can run several degrees warmer than the countryside around it, and the difference is largest at night, which is precisely when it does the most harm. Add to that the housing stock of the 1930s. Working families lived in the top floors of walk-ups because those floors were cheapest. Heat rises. The people with the least money slept closest to the roof, under tar that had spent the afternoon absorbing sunlight, in rooms that did not begin to cool until well after midnight, if they cooled at all. The eastern episode was brief. By the next day the pattern shifted west again, and highs in the northeast dropped back into the 90s, which felt like mercy. The dome had not weakened. It had simply repositioned itself over the middle of the country, where it would stay. That brevity is why the East is not the centre of this story. 3 days of extraordinary heat kill people, and they killed people that week. 2 weeks of relentless heat kill far more, because the harm accumulates in a way that a short spell never allows. The cities of the Midwest were about to find out what accumulation means. Nearly everything a person understands about heat comes from the afternoon. The night is where heat does its killing. The human body sheds warmth continuously. Blood moves toward the skin, sweat evaporates, and the core stays near 98 degrees while the surroundings do whatever they do. That system works well, and it works best when the air is cooler than the skin, so that heat flows outward without effort. When the air temperature climbs above roughly 95 degrees, the outward flow stops. The body can no longer simply radiate warmth away, and sweat becomes the only tool left. Sweating costs water and salt, and it works only if the sweat can evaporate. In an 85-degree bedroom with still, humid air, at 1 in the morning, after 14 hours of heat, an aging heart is pumping hard to push blood to the skin and getting very little cooling in return. What a body needs is a stretch of hours when the air drops far enough that the whole system can rest and reset. That is what a normal summer night gives. It is what that summer took away. At Springfield in Illinois, the overnight low failed to fall below 80 degrees for 8 nights in a row. On 2 of those nights, the temperature bottomed out at 84. Those remain the hottest nights ever recorded in that city. Farther north in Winnipeg, the thermometer on one night refused to drop below 83 degrees, which stands as the warmest night ever measured there, and perhaps anywhere in Canada. Later in the month, at Lincoln, Nebraska, an afternoon of 115 degrees was followed by a night in which the temperature bottomed out at 91. Outside the desert southwest, that is one of the highest overnight readings ever taken in the United States. Sit with that Lincoln number. At the coolest moment of the 24-hour cycle, in the hour before dawn, the air outside was still hot enough to prevent a resting body from cooling itself. Now put that night inside a brick building. Brick and stone hold heat. A wall that has absorbed sun since 7 in the morning keeps radiating that energy into the room until the small hours. Tar roofs do the same. A top-floor apartment in Detroit or Cleveland at midnight could easily be 10 degrees warmer than the street below, and the street below had not cooled either. This is the mechanism behind the death tolls, and it explains a fact that puzzled people at the time. The heat wave did not kill on the first hot day. It killed on the 4th, and the 5th, and the 6th. Each night of poor sleep and incomplete cooling left the body slightly worse off. Dehydration built up, blood thickened, hearts and kidneys that had been managing quietly for 70 years found themselves asked to do more than they could. Most of those who died did so in their own beds, or shortly after arriving at a hospital, and the newspapers filed the deaths under heart failure and prostration. Physicians of the period had a name for the acute version, sunstroke, and they associated it with labourers collapsing outdoors under a midday sun. The slower version, the one that empties nursing homes and top-floor apartments, had no name and no protocol. The idea that a heatwave produces excess deaths, and that you can count them by comparing the death rate that week against a normal week, would not become standard practice for decades. So the country was fighting an invisible thing. Every practical instinct people had was tuned to the afternoon. They watered the streets. They opened the fire hydrants. They handed out ice and cold drinks and sent the children to the beaches. All of that helps. None of it addresses the bedroom at 1 in the morning, which is where the summer took most of what it took. In one Midwestern city, the arithmetic of hot nights ran its course in a single, terrible week, and because the newspapers there kept careful count, the shape of it can still be read. Detroit in the 1930s had 63 years of weather records, and in all of that time it had never recorded 2 consecutive days of 100 degrees or more. Across those 63 years, the city had logged 7 such days in total. That week, it logged 7 in 7 days. The temperature reached the century mark and stayed there. Offices closed. Factories that had survived the worst of the Depression sent workers home at midday, because a foundry or a stamping plant in that heat was not a workplace. It was a hazard. Clerks at the Weather Bureau office stopped answering the telephone with a greeting. They picked up the receiver, shouted the current temperature into it, and hung up because every call was the same call. The federal forecaster said there was no relief in sight, and he was right. The deaths began in the way heat deaths always begin, quietly, at home, among the old. By the 5th straight day of triple-digit heat, the city had counted 122 dead. On that same day, 60 more people died in Detroit alone. Most of them were found inside their houses or died shortly after being carried into a hospital, with an overtaxed heart or a splitting headache as the last symptom anyone recorded. Most were elderly, not all of them were. A 14-month-old girl named Betty Lou Crawford died of heat prostration at Children's Hospital. A 34-year-old man named Walter Balco was found slumped in his car outside his own house, badly sunburned. The Free Press reported he had died of an internal hemorrhage. These are the names that survive because a reporter wrote them down, and behind each one stand hundreds who are listed only as a number in a coroner's weekly total. By the end of the week, the toll in the city had reached at least 364. The city did what it could think to do. People crowded into the parks and onto the playgrounds. They went to Belle Isle and to the lakes outside town and swam in water that had itself gone warm. They slept on lawns and in cemeteries and on the grass strips between roads, because outdoors, however hot, was cooler than the rooms they had. Ice deliveries ran out. Beer and lemonade sold in quantities the city had never seen. Even the zoo suffered. A chimpanzee named Susie, the star performer at the Detroit Zoo, went through a full Sunday of shows in the heat, roller skating and riding a bicycle for the crowds. She died of heat exhaustion the following morning. The detail is small, and it lands because it says plainly what the week was doing to every living body in that city, and because for a great many Detroiters, Susie was the death that made the abstraction real. Only one thing kept the city from setting its all-time record high that week, and it was luck. On the hottest afternoon, a layer of cloud drifted over Detroit and deflected enough sunlight to hold the thermometer just short of the mark. The cloud arrived by chance. Nothing in the pattern produced it, and nothing in the pattern promised another one. Of all the disasters that fell on Detroit during the Depression, the bank failures, the plant closures, the strikes, the political turmoil, the week the heat killed 364 people is the one that dropped out of the city's memory almost immediately. There are few monuments, there are few anniversaries. It arrived, it took what it took, and it was folded into the general misery of the decade. That is the ordinary fate of heat disasters. They leave nothing behind. A flood leaves a waterline on a wall. A tornado leaves a scar through a town that people point at for 50 years. Heat leaves an empty chair and a hot afternoon that looks exactly like the afternoon before it. 250 miles to the southwest, a much larger city was living through the same week, with a lake at its doorstep that turned out to be less help than anyone hoped. Chicago sits on a body of cold fresh water so large you cannot see across it, and that lake usually saves the city from the worst of a Midwestern summer. Air moving over Lake Michigan gives up heat to the water and arrives at the shoreline cooled. On a hot June day, the beaches can run 15 degrees below the neighborhoods 4 miles inland. That summer, the lake breeze failed to matter. At Midway Airport on the southwest side, the temperature climbed above 100 degrees and stayed there for 8 consecutive days. The wind through most of that stretch came out of the southwest, off the baked land of Illinois and Missouri, and it pushed the lake's influence out over the water instead of into the city. Only a thin strip along the shore felt any benefit at all. 8 miles west, in the bungalow blocks and the packed 2 flats of the west side, the air simply sat. About 200 people died in Chicago. Across Illinois as a whole, the count of heat deaths reported that July came to about 1,193, and Illinois is the one state for which a reasonably careful contemporary figure exists. Downstate, the numbers on the thermometer were worse than the cities. Springfield reached 113 degrees, breaking its all-time record by 6 degrees, a margin that almost never happens in weather records. Mount Vernon reached 114. Springfield logged 12 consecutive days at or above 100 and would finish the year with 23 such days. The Weather Bureau's summary for that month recorded 30 people in Springfield who died directly from the heat, with heat listed as a contributing factor in 20 more. That distinction, direct deaths and contributing deaths, is the whole difficulty of counting a heat wave, and it appears here for the first time in the record of that summer. A man with a failing heart who dies in a room at 104 degrees has died of heart failure. He has also died of the heat. Which line the coroner writes depends on the coroner. In Chicago, as in Detroit, people went looking for water, and water took its own toll. The lakefront filled. So did the Chicago River, the drainage canals, the quarries outside town, and every farm pond within reach of a bicycle. Across the Midwest that summer, a large share of the deaths attributed to the heat were drownings, men and boys mostly, who went into water they did not know, at the end of a day when they were already exhausted and dehydrated. Wisconsin's death figures include drownings for exactly this reason. It is one of the reasons the phrase heat-related death covers more ground than people expect. The city opened its parks around the clock. Families carried blankets to Grant Park, Lincoln Park, Humboldt Park, and Washington Park, and slept on the grass in their thousands. Police were instructed to let them alone. Fire hydrants ran in the streets, which cooled the children playing in them, and did nothing at all for the woman on the third floor. Movie theatres became refuges, and they became the first mass experience of mechanical cooling in American life. The big downtown houses had installed refrigeration in the 1920s as a novelty, advertising it with icicle lettering on the marquee. In that summer, people bought a ticket for the cold, sat through the feature twice, and dozed. That is where an entire generation learned what air conditioning was, and it is one of the reasons the technology moved so quickly from luxury toward necessity in the decades after. The theatres held a few thousand people. The city held 3.5 million. The heat had not finished. The dome slid slightly, and the worst single day of the entire summer, the day that broke more records in more places than any other, was still ahead. It arrived first over the dairy country of the north. Of the 88 Weather Bureau stations operating in Wisconsin that summer, 87 reached 100 degrees or more. The lone exception sat on Plum Island, a speck of rock in the passage off the tip of the Dore Peninsula, surrounded on all sides by the cold water of Lake Michigan. The Coast Guard observer there recorded a monthly maximum of 94 degrees. Everywhere else in the state, the heat came through without obstruction. On the worst day, the average high temperature across the whole of Wisconsin was 96 degrees. That is the average, taken from stations on Lake Superior and stations in the driftless hills and stations in the northern forest. 71 stations across the state set all-time record highs that summer, most of them within a few days of one another, and at Wisconsin Dells the thermometer read 114 degrees. 9 decades later, that reading remains the highest temperature ever recorded in Wisconsin. The same afternoon, 400 miles east, the little town of Mio sat in the valley of the Osable River in northern Michigan, in country better known for trout streams and pine. Mio recorded 112 degrees, and it holds the Michigan record to this day. Saginaw reached 111. Something worth noticing runs through those two records. Wisconsin Dells lies in a river valley. Mio lies in a river valley. On nights and mornings, cool air drains downhill and pools in low ground, and by the same token, on a scorching afternoon with a light wind, valley floors can trap and bake the air above them. The stations that set the extreme records were often in exactly this kind of terrain, which is one reason a state record can look strange next to the numbers from the nearest city. The mechanism that day was straightforward. A southerly wind carried air that had been superheated over the ploughed and desiccated ground of Iowa and Illinois straight north across Wisconsin, under a cloudless sky, in the middle of July. The state had received less than an inch of rain that month. There was no moisture in the soil to spend on evaporation, and no moisture in the air to build a cloud. The energy had one place to go. The cost in Wisconsin was severe. Estimates put the state's toll above 450 people, from heat stroke and from drowning in the lakes where they had gone looking for relief. Farmers watched their corn crop finish in a matter of days. Pastures failed, and dairy herds that had been the state's living began to go dry. There is a photograph from Minnesota that summer of people asleep on the grass of a public park, dozens of them, adults and children under sheets, in the dark. Nothing about it is dramatic. It is the most accurate picture of what that summer actually was that anyone took. A whole population outside at night, because inside had become the dangerous place, and the only technology available to them was to go where the air was. The heat dome had by then been holding its position for more than a week. Around it, the same clockwise flow that had swept the east, and then the Great Lakes was carrying the hottest air of all toward the corn country south of Wisconsin. The following afternoon would be the peak, and it would take place over the most heavily farmed and densely settled ground the dome ever covered. At Collegeville, in northwestern Indiana, on the flat black soil of the old Grand Kankakee Marsh, the observer read 116 degrees. That reading is still the Indiana state record. It was set on the day that most of the country's records fell together, the single peak of the whole summer for the Corn Belt and the Mississippi Valley. At Mount Vernon, in southern Illinois, the thermometer reached 114. At La Crosse, on the Mississippi and Wisconsin, 108, which is still the hottest day that city has ever seen. In St. Louis, 108. In Springfield, Illinois, 110 that afternoon, and 113 the following day. In Kansas, the heat crossed into the plains, with Wichita at 101, Tulsa at 107, and Fort Smith, Arkansas at 106, all of them warming up for what the second half of the month would bring them. Run your eye across those cities and you are looking at the most valuable farmland in the world and at the towns and river ports built to move what it grows. It is not empty country. It was at the time home to tens of millions of people living in wood frame houses and brick blocks with no cooling of any kind. What was happening in the corn that day is worth understanding, because it explains the food prices that followed. Corn pollinates in July. The tassel sheds pollen, the silk on each young ear catches it, and every grain of pollen that finds a silk becomes a kernel. The process takes about a week, and it is exquisitely sensitive to heat and dryness. Above roughly 95 degrees, pollen loses viability quickly. In dry air, the silks desiccate before the pollen arrives. A field can look green and healthy in the last week of July and produce almost nothing, because the plant has already failed at the one job that makes it a crop. Across Illinois, Indiana, Iowa, and Missouri, the peak of the heat wave landed precisely on the pollination window. The failure was not a matter of wilted leaves. It happened invisibly, at the top of the plant in the space of a few afternoons. Farmers who walked their fields in August peeled back the husks and found bare cobs were looking at the record of a single week in July. Livestock fared no better. Hogs have almost no ability to sweat, and hogs died in their thousands across the Corn Belt in barns that reached temperatures higher than the air outside. Chickens died. Dairy cattle stopped producing. The Humane Society of Missouri distributed buckets to filling stations along the roads so that draft horses hauling wagons through St. Louis could be given water, because horses were still doing much of the city's short-haul work and they were dropping in the traces. By this point, the heat had been running for the better part of 2 weeks. The soil moisture that might have moderated the afternoons was long gone. Reservoirs and wells were falling, and the human toll, which had been mounting quietly in bedrooms across a dozen states, had begun to reach the scale where public officials could no longer treat it as an unusual run of natural deaths. The relief people kept waiting for did arrive, in the north. An area of low pressure finally shouldered across the upper Mississippi Valley, broke the dome's grip over Wisconsin and Minnesota, and dropped temperatures back toward normal. The northern half of the story ends there. Farther south, along the Mississippi, one city was keeping a careful ledger, and its ledger would run all the way to the end of August. St. Louis, in the summer of 1936, recorded 37 days on which the temperature reached 100 degrees or more. That is the record for the city, and it has never been approached. 18 of those days fell in July. The heat reached its peak at 108 degrees on the day the Corn Belt records fell, which still ranks among the 10 hottest days in the city's history. By the end of the month, when a run of cooler air finally moved through and people slept indoors for the first time in weeks, the city had counted 332 dead. The relief lasted about 10 days. In the second week of August, the temperature climbed back to 100. Over the following 18 days, it reached that mark on 15 of them, and topped 103 on 11. Near the end of the month, it hit 106. Tar roofs on the brick homes and flats of the south side softened and ran. The heat buckled brick pavement at street corners, lifting the bricks out of their bed, and photographers went out and made pictures of children standing on the wreckage of their own street. When the summer ended, the count of the dead in the St. Louis area stood at 479 people. 29 of them were children. That number is worth holding because of how it was arrived at. St. Louis had a large newspaper with a working city desk, a coroner's office that kept records, and a public health department that paid attention. The figure of 479 is not a national estimate scaled down. It is a count. It is very likely still an undercount, for the same reason every heat toll is an undercount, but it is a count, and it is why this one city appears in every serious history of that summer, while cities of comparable size appear nowhere at all. What people did to survive is documented in the same photographs. Thousands of families abandoned their houses at nightfall and slept for weeks in the city parks, on the grass at Forest Park and Tower Grove, and along the quiet country roads out in the county. They took blankets and pillows and small children, and they lay down in the open night after night. A family photographed near Lindbergh Road looks like a family on a picnic, except that it is dark and they are not eating. The river told the same story from a different direction. The Mississippi at the downtown gauge fell below the 0 mark and stayed there for weeks. A ferry sat stranded on the levee south of the Eads Bridge, hull on mud, going nowhere. Out in the countryside, farmers who had lost their wells hauled water from the city works and paid 44 cents for every 1,000 gallons, which was real money in a year when a farm labourer might earn $1.50 a day. Mrs. W. E. Johnson, working a farm north of Columbia, Missouri, spent her August in a potato patch that had produced shriveled tubers the size of marbles. Rainfall in that part of the state came to about 1/4 of normal for the season. Here is the thing that a modern reader tends to miss. Nobody in St. Louis, in Detroit, in Chicago, in Milwaukee or in Cleveland was told that they were living through a public health emergency, because no institution existed that would have made that declaration. There was no threshold, no warning category, no advisory. The Weather Bureau forecast the temperature. It did not forecast the risk. Whether you understood that your mother on the 3rd floor was in danger depended entirely on whether you happened to think of it yourself. 479 people in one metropolitan area, about 200 in Chicago, at least 364 in Detroit, more than 450 across Wisconsin, 284 across Indiana, 51 in Minneapolis. Add the cities that kept no count, and the towns and the farms, and the number grows into the thousands. What that number actually is, and why it has never been settled, is a question that runs to the heart of what a heatwave is, and how a country decides who died of what. The body is a furnace that runs at 98.6 degrees and never shuts off. Every heartbeat, every breath, every thought produces waste heat, and all of it has to go somewhere. In an ordinary summer, it goes out through the skin, carried away by air that is cooler than you are, and by sweat that lifts off the surface and takes energy with it as it evaporates. That system has a breaking point, and the breaking point is not a single temperature. It is a combination of temperature, humidity, time, and the person. When the air outside is cooler than skin, roughly 95 degrees or below, warmth flows out of you without any effort at all. Above that, the flow reverses. The air begins delivering heat into your body instead of taking it away, and the only remaining tool is sweat. Sweat works only if it can evaporate, and evaporation slows as the air fills with moisture. This is why a dry 115 degrees on the high plains is survivable for a healthy person with water and shade, and why a humid 98 degrees in a closed room in St. Louis is not survivable for an 80-year-old over 5 days. Sweating costs water and salt. A person working outdoors in extreme heat can lose more than a quart of fluid an hour. As that water leaves, blood volume falls and blood thickens. To keep cooling the skin, the heart has to push harder and faster through a smaller supply. For a young heart, that is an inconvenience. For a heart that has been quietly compensating for 40 years of high blood pressure, it is the demand that finally breaks it. Most people who die in a heat wave die of that. Their hearts fail, or their kidneys fail as blood is pulled away from them toward the skin, or the strain finishes off something that was already failing. The coroner writes cardiac arrest. The death certificate never mentions the weather. The dramatic version has a name. Heat stroke happens when the core temperature climbs past about 104 degrees and the body's controls collapse. Sweating stops. The skin goes dry and hot. Confusion sets in, then loss of consciousness, then organ damage. Heat stroke can kill in hours, and even with modern emergency cooling, it kills a significant share of the people it takes. In the 1930s, it was called sunstroke, and it was understood as something that happened to labourers in the noon sun. The word itself pointed people in the wrong direction. It taught them to fear the afternoon and to ignore the bedroom. Some people are far more vulnerable than others, and the pattern has not changed in 90 years. The elderly cool themselves poorly. Sweat production declines with age, the sense of thirst dulls, and many take medications that interfere with sweating or with the heart's ability to speed up. Infants have a large surface area relative to their mass and cannot ask for water or move themselves to a cooler room. People with heart disease, lung disease, kidney disease and diabetes have less reserve to spend. So do people taking certain psychiatric medications. And poverty, in every heat wave ever studied, is itself a risk factor, because poverty determines what floor you live on. whether your windows open onto air or onto a shaft, and whether you can afford to leave. That summer, in Detroit and St. Louis and Chicago, the dead were overwhelmingly old, overwhelmingly poor, and overwhelmingly found indoors. The same sentence describes the Chicago heatwave of the 1990s, and the Paris heatwave of 2003, and the Pacific Northwest heat dome of 2021. The guidance that public health agencies give today follows directly from the physiology. Drink water before you feel thirsty. Spend a few hours of the hottest part of the day somewhere cooled, even if your own home is not, because a break in the middle of the day resets the body meaningfully. Move air across your skin, since a fan helps as long as the air is below about 95 degrees. Wet the skin and let it evaporate. Avoid heavy exertion in the afternoon. Never leave anyone in a parked car, not for a minute, and check on the old people you know, in person if you can, once in the morning and once in the evening, because the person most at risk is the one least likely to call for help. None of that advice existed as advice in 1936. What existed instead was improvisation, and the country improvised on an enormous scale. The window fan had barely been invented. The room air conditioner would not go into wide production for another decade. What Americans had in that summer was ice, water, shade, and the night. Ice came on a wagon or a truck in blocks, and it went into an insulated wooden cabinet called an icebox. Perhaps half of urban households had mechanical refrigeration by then. The rest bought a block every few days and set a pan underneath to catch the melt. In the heat wave, the ice ran out. Ice companies worked around the clock and could not keep up, and in city after city the price rose past what a family on relief could pay. In New York, decades earlier, a young police commissioner named Theodore Roosevelt had made a name for himself by giving ice away in the tenement districts during a deadly heat wave. The lesson stuck in New York. It had not become national policy. Electric fans existed and were common enough in offices, less so in the top-floor rooms where people were dying. A fan does something real. It moves air across the skin, which speeds evaporation, and strips away the thin layer of warm, humid air that clings to a body at rest. But a fan is not a cooler. When the air itself passes about 95 degrees, blowing it harder across a person delivers heat rather than removing it, the way a convection oven cooks faster than a still one. In a bedroom at 100 degrees, a fan pointed at a sleeping person is doing very little, and may be doing harm. So people went outside. They slept in the parks, in their thousands, in every city the heat touched. They slept on fire escapes, on flat roofs, in cemeteries, on the docks, on lawns, on the strips of grass between the sidewalk and the curb. In Chicago, the police were told to leave the park sleepers alone. In St. Louis, the families went out into the county and lay down along the shoulders of quiet roads. In New York, tens of thousands lay on the piers along the rivers. Photographs from Minnesota show whole families under sheets on public grass, adults and children together, in the dark. This is not a quaint detail. It was the single most effective thing anyone did that summer, because a body outdoors under an open sky loses heat by radiation to the night air in a way that a body inside a brick box cannot. The people who slept in the parks were following, without knowing it, the exact physics of the situation. They also went into the water, and there the improvisation turned lethal. Rivers, quarries, canals and farm ponds filled with people who could not swim, at the end of days when they were already dehydrated and exhausted. Drownings account for a real share of that summer's death toll, particularly in Wisconsin and across the upper Midwest. In the accounting that came later, those deaths are usually filed as heat-related, and they belong there. The heat put them in the water, and then there were the theatres. The big downtown movie palaces had installed mechanical cooling in the 1920s, mostly as a gimmick to keep summer ticket sales alive. They advertised it on the marquee with lettering shaped like icicles. In the summer of the great heat, those theatres became something else. People bought a ticket in the morning and stayed through 2 showings. Some slept. The theatre was cool because a machine was making it cool, and for millions of Americans that was the first time they had ever stood inside conditioned air. It is difficult to overstate what that did to public expectations. The generation that sat through a double feature to escape that summer went on after the war, to buy window units and then central systems as fast as they could afford them. Air conditioning stopped being a luxury and became, in most of the country, the standard by which a house is considered fit to live in. That change is one of the largest public health interventions in American history, and nobody planned it. It came out of the ticket booth. None of it arrived in time for anyone that July. In the meantime, the dome had shifted south and west, and the plains, which had watched the Great Lakes burn, were about to record temperatures that no other part of the country has ever matched. The relief that broke the heat over Wisconsin and Minnesota did nothing for Kansas. As the dome repositioned itself over the southern plains, the readings there passed anything the Corn Belt had produced. At Fredonia, in southeastern Kansas, the thermometer reached 121 degrees. It ties the Kansas state record, which was matched again the following week at Alton, in the north of the state. Salina reached 116, Wichita reached 112, Topeka reached 110. On the same day, at Alva in northwestern Oklahoma, the reading was 120. That is the Oklahoma state record. It was tied the next day at Altus, 3 counties south. Tulsa reached 113, its hottest July day ever measured. Missouri set its record at Clinton, 118 degrees, and matched it at Lamar a few days later. Then, briefly, the pattern eased. For the first time in almost 2 weeks, most of the country dropped below 100 degrees. People slept indoors. Newspapers wrote about the end of the heat wave. It was not the end. The dome contracted rather than dissolving, and over the last week of the month it reasserted itself across Nebraska, Iowa, and Kansas with an intensity that the region has never seen since. At Hartington, Nebraska, 118 degrees. At Grand Island, 117. At Omaha, 114. At Lincoln, 115 degrees on the hottest afternoon, and that night the temperature fell only to 91. Outside the deserts of the southwest, that is one of the highest overnight low temperatures ever recorded in the United States, and it is the single number from that summer that best explains why people died. There was no hour of the night in Lincoln, Nebraska, when a human being could rest and cool. Nebraska's record was matched again at Minden, 118 degrees at the end of the month. Across the line in Iowa, at Atlantic and again at Logan, the thermometer reached 117, and those readings stand as the Iowa state record today. Des Moines hit 110. Look at what those places have in common. They are farm towns, on rolling ground, hundreds of miles from any ocean, sitting on soil that had been ploughed and left bare and had not had a soaking rain in years. Nothing about their geography makes them hot. Nothing about a normal July in Nebraska produces 118 degrees. The number is a product of the ground beneath the thermometer, not the latitude above it. That is the point the plains made in the last 2 weeks of that month, and it is the reason meteorologists still study this event rather than filing it away as an old curiosity. Given a persistent ridge of high pressure and enough weeks of drought, the interior of North America can generate temperatures that belong in the Sonoran Desert. The atmosphere does not have a fixed ceiling. It has a ceiling set by how much water is available to evaporate, and in that summer, across a quarter of the country, the answer was almost none. For the people living there, the effect was different from the effect in the cities. Farm families were not dying by the hundreds because they were not stacked 6 stories high in brick. They were watching their year end. Wells failed. Windmills pumped air. The corn they had planted in May had already burned, and the wheat behind it, and the pasture that was supposed to carry the cattle through August. Some families slept in cellars. Some pulled their mattresses out under the cottonwoods along a creek that had stopped running. Kansas and Oklahoma had spent 3 years learning what dust could do. That July they learned that the same bare ground, on a still afternoon under a cloudless sky, could do something quieter and just as final. There was no black wall on the horizon. There was only a thermometer reading 121 degrees and a field of corn that had finished dying 2 weeks earlier. The dying of that corn had consequences that reached every kitchen table in America. A cornfield in July is a factory with 1 week to do its work. The tassel at the top of the stalk releases pollen. The silk emerging from each young ear catches it. Every kernel on the finished cob is the record of 1 grain of pollen landing on 1 strand of silk. The process runs for about a week, and it is the single most vulnerable moment in the plant's life. Pollen begins losing viability above about 95 degrees. Silks dry and shrivel in low humidity. A plant under severe drought will delay putting out silk while the tassel sheds anyway, so the pollen falls on nothing, and the timing that has to line up simply does not. The result is an ear with scattered kernels, or an ear with none, on a stalk that stands there looking passable until you tear the husk open in September. That summer, the peak of the heat wave arrived directly on top of the pollination window across Illinois, Indiana, Iowa, and Missouri. The Corn Belt lost its crop in the space of a few afternoons, and most farmers did not know it for another month. Wheat had gone earlier, burned in the field on the plains before it filled. Pasture went the colour of straw and stayed there. Hay yields collapsed, which meant that even farmers who kept their animals alive through August had nothing to feed them through winter. Across the continent, corn and wheat prices rose quickly, and they kept rising, because the country was buying from a harvest that did not exist. Rising grain prices in a normal year mean money for farmers. In that year they meant almost nothing to the men who grew grain, because those men had no grain to sell. What the price rise did instead was reach into the cities and raise the cost of bread, of milk, of eggs, of pork in the 7th year of the Great Depression, among people who were already spending most of what they had on food. The animals suffered first and most visibly. Hogs cannot sweat. A pig cools itself by lying against damp ground or in water, and a hog barn in 100-degree weather becomes hotter than the field outside it. Hogs died in enormous numbers across the Corn Belt. Chickens died in their coops. Dairy cattle stopped giving milk because a cow under heat stress eats less, and a cow that eats less produces less, and the Wisconsin dairy herd that was the backbone of that state's economy went slack for the season. In Missouri, farmers whose wells had failed drove to the city waterworks and bought water by the tank, 44 cents for every 1,000 gallons, and hauled it home to keep livestock alive. That is a transaction worth pausing on. A farm exists to produce food from land and water. When the water has to be trucked in from town and paid for by the gallon, the farm has stopped being a farm and become a holding operation, waiting for rain. The Humane Society of Missouri distributed buckets to filling stations across St. Louis so that draft horses could be watered on their routes. Horses were still hauling ice, coal, and produce through American cities in that decade, and they were collapsing in the traces. Then there were the cattle themselves. Federal buying programs from earlier in the drought had already purchased and destroyed millions of head across the plains because there was nothing to feed them and no market for them. The summer of the great heat pushed another wave of families past the point where staying made sense. The migration out of the plains that gets remembered through photographs of loaded cars on the highway had been running for years. That summer added to it. The harvest failure was not evenly spread, and it should not be overstated. Parts of the country away from the dome brought in ordinary crops, and the nation did not go hungry. What happened was narrower and still severe. The most productive farmland in the world had its worst year of the century, at the worst possible economic moment, because of a single week of weather that arrived at exactly the wrong point in the growing calendar. The water that failed the corn was failing everywhere else too, and you could measure it by walking down to the river. There is a gauge on the Mississippi River at St. Louis, and it has a 0 mark on it that does not mean an empty river. It means a particular reference level set long ago, that the water is expected to stay comfortably above. That summer, the river fell below 0 and stayed there for weeks. A ferry sat stranded on the levee south of the Eads Bridge. Hull settled on mud, waiting for water that did not come. Sandbars surfaced in channels that had carried barge traffic all century. Towboat pilots who had run the river for 30 years found themselves reading the water like a stranger. A river is a drought gauge with a long memory. Rain that falls in Minnesota in April is still moving through the Mississippi at Memphis in June. When a whole basin stops receiving rain, the river does not drop immediately. It drops slowly, weeks after the fields have already burned, as the groundwater that feeds the tributaries between rains runs down. By late summer that year, the rivers of the central United States were reporting what the soil had known since spring. The same thing was happening on a smaller scale everywhere. Creeks that ran year-round stopped running. Stock ponds went to cracked mud with a ring of hoofprints around the edge. Shallow wells, the kind a farm family had hand-dug 2 generations earlier, came up dry, and the deeper wells that replaced them were expensive in a year when nobody had money. Municipal reservoirs in small towns dropped low enough that officials began rationing. Low water is not merely a shortage. It is a heat problem in its own right, and this is where the whole story closes into a loop. Water absorbs and stores enormous amounts of energy. A full river, a full reservoir, a wet marsh, a saturated field, all of these act as a brake on temperature, taking in sunlight and turning it into evaporation rather than into hot air. As they dry, that brake releases. The remaining water also gets hotter, faster, because there is less of it to heat. Shallow, warm water holds less dissolved oxygen, and fish kills followed across the Midwest that summer, in rivers and in the lakes where people had gone swimming. Even the swimming became less useful. The lakes and quarries that people drove to on the worst afternoons had themselves warmed, so that a body immersed in them shed heat more slowly than it would have in June. The Great Lakes were the exception, because their sheer volume made them nearly immune to a single season. Lake Michigan stayed cold. That is why the observer on Plum Island recorded 94 degrees for the month while the rest of Wisconsin baked, and why the Chicago lakefront was measurably cooler than the neighborhoods 4 miles inland. It is also why the lake failed to save Chicago. A cold lake only helps if the wind blows across it toward you, and for 8 straight days the wind came the other way. Modern drought monitoring measures all of this on purpose. Satellites track soil moisture. Stream gauges report by the hour. Reservoir levels are public. Forecasters have learned to look at the state of the land in spring as a leading indicator of how hot the following summer can get, because the mechanism that drove that year is not a historical curiosity. It runs every summer, in the background, in both directions. In the summer of 1936, nobody was watching any of it, and the loop closed without anyone naming it. Dry ground made hot air made dry ground. Rivers fell. The land grew a little less able to cool itself each week. The northern half of the country had earned its reprieve at last. The southern half had not yet had its turn. Late in July, cooler air moved through, and for the second time that summer, the country believed the thing was over. St. Louis dropped below 100 degrees at the end of the month. Chicago cooled. The parks emptied and people carried their blankets back upstairs. Newspapers moved the weather off the front page. 10 days later, the temperature in St. Louis was back at 100. The heat that returned in August behaved differently. The dome had drifted south, and the states that had escaped the worst of July now took the full weight of it. August finished as the warmest month ever recorded for 5 states. Texas set its all-time record. At Seymour, in the north-central part of the state, the thermometer reached 120 degrees. That reading has never been beaten in Texas, which has been keeping records for well over a century and contains a great deal of desert. Arkansas set its record at Ozark, 120 degrees. Louisiana set its record at Plain Dealing, 114. Both of those still stand. Across the South, towns recorded long strings of consecutive days above 100, the kind of stretch that grinds down a population rather than shocking it. Drought worsened in a region that had already lost a spring crop. St. Louis, which had suffered through 18 days of 100-degree heat in July, went through 15 more in the 18 days after the second wave arrived. On 11 of those days, the temperature reached 103 or higher. Near the end of the month, it reached 106. Tar roofs melted. Brick pavement buckled at intersections and had to be relaid. By then, the city's death toll had climbed from 332 to 479. That progression is the most important thing in this chapter, and it is not about Texas or Arkansas. It is about what a second wave does to a population that has already been through a first one. People who survive a long heat wave do not come out of it whole. They come out dehydrated, having lost weight, having slept badly for 3 weeks, with hearts and kidneys that have been running at the edge of what they can do. An 80-year-old who made it through July was in worse condition on the first day of the second wave than she had been on the first day of the first. The margin was gone. Public health researchers who study heat now watch for exactly this. The second event in a season is deadlier than its temperatures alone would predict, because it lands on a population that has already spent its reserves. The same logic explains why the 4th and 5th days of any single heat wave kill more people than the first and second. It also explains a fact about that summer that surprises people. The absolute highest temperatures in the United States that year, the 121 in Kansas and North Dakota, the 120 in Oklahoma and Texas and Arkansas, were recorded in places where relatively few people died. The deaths concentrated where the heat was merely severe, and where it lasted, and where it was joined by brick, by crowding, by poverty, and by age. The heat finally broke for good with scattered rain toward the end of August. It had run, with one pause, for something close to 2 months. What it left behind was a country of failed farms, empty pastures, low rivers, and an unknown number of graves. The word unknown is doing a great deal of work in that sentence, and it has been doing that work for 90 years. How many Americans died in the summer of 1936 is a question with 3 defensible answers, and the distance between them tells you something important about heat itself. The first answer comes from the government of the day. The United States Department of Commerce published a volume called Mortality Statistics for that year, compiling death certificates from the states that participated in the National Registration System. It records 4,678 deaths attributed to excessive heat. For comparison, the same publication records 728 such deaths in the previous year. That comparison is the cleanest single fact in this entire story. In an ordinary year, heat killed a few hundred Americans by the reckoning of the coroners of the time. In that year, it killed nearly 5,000 by the same reckoning, applied by the same officials, using the same standards. Whatever the true figure is, the event was roughly 6 times worse than normal by the only consistent measure anyone kept. The second answer is the round number that appears in almost every account, including the National Weather Service's own regional histories, about 5,000. It is the commerce figure, softened at the edges, plus the deaths from states and counties that reported poorly or not at all. The third answer is much smaller, and it is instructive. The International Disaster Database that researchers use for cross-country comparisons lists the North American heat wave of that summer at 1,693 deaths, which places it 6th among the deadliest heat waves in modern world history. That figure is almost certainly far too low. It appears to rest on the 1,193 heat deaths reported in Illinois that July, plus about 500 from Canada. Everything else is missing, not because the deaths did not happen, but because nobody entered them in a database that would not exist for another 50 years. Set the 3 answers side by side, and you can see the shape of the problem. The event is enormous. The counting is fragile. The number that ends up in the reference works depends on which record survived. Then there is the fourth answer, which nobody has ever calculated for that summer, and which is almost certainly the largest of all. Modern epidemiologists do not count heat deaths by reading death certificates. They count excess deaths. They take the number of people who died in a city during the heat wave, compare it against the number who would ordinarily have died in that city in that week, and attribute the difference to the event. The method captures the heart attack that would not have happened, the stroke that came 3 years early, the elderly man with pneumonia whose body could not manage one more insult. In every heat wave where both methods have been applied, the excess death count is several times larger than the number of certificates that say heat. Applying that method to 1936 is probably impossible now. The weekly mortality data for most of the country does not exist in usable form, and the baseline for a normal week during the Depression is itself unstable. What can be said with confidence is this: 5,000 is the accepted figure. It is the largest heat toll in the American record. It is also, by the standards of modern counting, a floor rather than a ceiling, and even that floor sits uneasily. Other American heat events have been credited with higher figures by some historians, particularly a stretch of extreme heat in the East around the turn of the 20th century, when record-keeping was worse still. Those claims rest on newspaper tallies rather than on any national compilation. The honest statement is that 1936 holds the title on the strength of the best documentation anyone has, not on the strength of a count that anyone would call complete. The temperature records from that summer are a different matter entirely. Those were written down carefully at the time by trained observers, and most of them are still standing. 90 years is a long time for a weather record to survive. The climate of the United States has warmed measurably since that decade. There are far more thermometers now, in far more places, which means far more chances to catch an extreme. Instruments are better. Reporting is instantaneous. Every summer, somewhere in the country, records fall. And yet, as of the most recent tallies, 13 states still hold all-time high temperature records set in the summer of 1936. Counting the readings that tied earlier records, 17 states either broke or matched their all-time maximum during that one summer. The list runs across the middle of the country like a scar. North Dakota, 121 degrees, Kansas, 121, Oklahoma, 120, Texas, 120, Arkansas, 120, Missouri and Nebraska, 118, Iowa, 117, Indiana, 116, Minnesota and Wisconsin, 114, Louisiana, 114, Michigan and West Virginia, 112, Pennsylvania, 111, New Jersey, 110, Maryland, 109. 71 individual weather stations in Wisconsin set all-time highs that summer. In Illinois, in Michigan, in Missouri, dozens more did the same. Many of those station records stood untouched until the heat of 2012, and a great many were not touched even then. The monthly figure is the one that keeps climatologists interested. Averaged across every station in the lower 48 states, that July came in at 76.8 degrees, which is about 3.2 degrees above the average for the 20th century. It remains the warmest month ever recorded in the contiguous United States, in a record that begins in 1895. That statement has wobbled once. In 2012, after another brutal July, the National Oceanic and Atmospheric Administration announced that the new month had edged past the old one. 2 years later, after a routine reanalysis that incorporated newly digitized station records and improved quality control, 1936 went back on top by a margin of about 0.02 of a degree. Some people saw the reversal as evidence of tampering. What it actually shows is how close the 2 months are, and how a difference that small can flip when a few hundred paper ledgers from small towns are finally keyed into a database. 0.02 of a degree is not a meaningful distinction. The honest reading is that the summer of 1936 and the summer of 2012 produced the 2 hottest months in the American record, and that they are effectively tied. The seasonal record has moved. That summer was the warmest summer in the American record for 85 years, until the summer of 2021 passed it. There is a temptation, when a very old record refuses to fall, to conclude that nothing has changed. That conclusion does not survive contact with the data. Individual extreme readings are set by local circumstances, and the local circumstances of the Dust Bowl were extraordinary. Nationally, the number of hot days has climbed, the number of hot nights has climbed faster, and the average summer is warmer than it was. What the standing records really tell you is what happens when a warming atmosphere meets exhausted ground. It is not a comforting message. Why the atmosphere behaved as it did that summer is the last piece of the mechanism, and parts of it remain unsettled. Meteorologists have been arguing about the causes of that summer for most of a century, and the argument has produced one solid conclusion, one widely accepted theory, and several honest gaps. Start with what is confirmed. The immediate cause was a persistent ridge of high pressure over the central and northern plains that held its position for most of July, with a second high over the southeast, and, for part of the period, a third that drifted down over Colorado and reinforced the whole arrangement. Beneath a ridge, air sinks, warms by compression, and dries. Clouds do not form. Thunderstorms do not develop. The jet stream and the cool fronts it carries were displaced far north into Canada. This is not in dispute. It is written plainly on the surface maps the Weather Bureau drew twice a day, and any forecaster today would recognize the pattern instantly. The harder question is why the ridge stayed. Ridges build and collapse all the time. The ones that matter are the ones that lock in place for weeks. A few of the usual suspects can be eliminated. There was no La Niña that summer. La Niña conditions in the tropical Pacific often tilt the odds toward hot, dry summers in the central United States, and their absence means the standard explanation does not apply. The Pacific Decadal Oscillation, a slower pattern of sea surface temperatures across the northern Pacific, was in a strongly positive phase, according to the reconstructions. Whether that contributed, and how much, is not something anyone can state with confidence. The widely accepted theory concerns the land. By 1936, the drought was in its 3rd year, and the ploughing of the previous 2 decades had stripped the deep-rooted prairie sod from a vast area of the plains and replaced it with wheat that had failed. Across an enormous surface, there was no vegetation, no cover, and almost no soil moisture. Sunlight that would ordinarily have been spent evaporating water was instead spent heating the ground and the air directly above it. That does two things. It raises temperatures locally, which everyone accepts. It also alters the atmosphere above, making the air over the region warmer and less dense, which encourages a ridge to build there and to persist. Climate modelers who have tried to reproduce that summer in simulations have generally found that they cannot get the observed temperatures using the ocean patterns of the era alone. When they add degraded land surface and depleted soil moisture, the model gets much closer to what the thermometers actually recorded. So the working explanation is a partnership. A natural circulation pattern parked a ridge over the middle of the country. Land that human beings had stripped bare made the air beneath that ridge hotter than it would otherwise have been, and helped hold the ridge in place. The two fed each other for 6 weeks. That is a theory, well supported and widely held. It is not a measurement. Nobody in 1936 was sampling soil moisture across the plains, and nobody was measuring the upper atmosphere in a way that would let a modern scientist reconstruct the ridge in 3 dimensions. The models fill the gap with physics and assumption. They are persuasive. They are not the same as data. What can be said without hedging is that the summer required both halves. Ridges of high pressure had parked over the plains before and would again, without producing anything like this. Drought had gripped the region for 2 years before this, and produced dust storms rather than 120-degree afternoons. It took the sky and the ground together. The people who lived through it drew that conclusion themselves, and by the end of the decade they were doing something about the half they could control. The response to the Dust Bowl and the summer that capped it was the largest deliberate change ever made to the surface of the American plains. The Soil Conservation Service had been created the year before the heat wave, out of an earlier temporary agency, and it went to work on a simple premise. The dirt was blowing and baking because nothing was holding it. So put something back. That meant contour ploughing, which follows the curve of a slope instead of running straight down it, so that water soaks in rather than running off. It meant terracing on steeper ground. It meant crop rotation and cover crops, so that a field was never left bare through a dry season. It meant leaving stubble on the surface after harvest instead of turning it under. It meant, on land that should never have been broken at all, taking it out of cultivation entirely and letting grass come back. And it meant trees, in quantities that are difficult to imagine now. The Prairie States Forestry Project, launched 2 years before the heat wave and running until the war, planted shelter belts across a strip from the Texas Panhandle to the Canadian line. Rows of trees, set at intervals across the open country, to slow the wind at ground level. Over roughly 8 years, the project planted something on the order of 200 million trees on tens of thousands of farms. Many of those belts are still standing. If you drive across western Nebraska or Kansas today, and notice the regular lines of cottonwood and honey locust running north and south across the fields, you're looking at the government's answer to that decade. The measures worked, imperfectly. Drought returned to the plains in the 1950s, as severe by some measures as the 30s, and it produced dust storms and hardship. It did not produce anything like the same catastrophe, and one important reason is that the ground had cover and the ground held water. The other change came from the market rather than from Washington. Air conditioning moved from the movie palace into the department store, then the office building, then, after the war, into ordinary houses. The window unit made it affordable. By the 1970s, a majority of American homes had some form of cooling. Today the figure is close to 9 in 10. That single technology has probably saved more American lives from heat than every public policy combined. Studies of heat mortality across the 20th century find that the relationship between hot days and deaths weakened dramatically as air conditioning spread, and that the timing of the improvement in any given region tracks the timing of adoption. It also created a new dependency and a new inequality. A house without cooling in a country built around cooling is more dangerous than a house without cooling in a country where nobody has it, because the buildings themselves are designed on the assumption that a machine will do the work. Modern apartments have windows that barely open, no cross ventilation, no shade trees, no thick masonry walls. When a heat wave knocks out the power grid, the population it strands is far less prepared than the people who slept in the parks of Chicago in 1936, because those people knew how to sleep in a park. The last piece of the response took longest. It was the recognition that heat is a public health emergency that requires warning, and that recognition did not really arrive until a city very much like the ones in this story, lost hundreds of people in a single week, nearly 60 years later. Chicago, in the middle of July in 1995, went through 5 days of extreme heat. The temperature reached 106 degrees, the humidity was high, and the nights stayed warm. The city's public health system counted 739 excess deaths. Almost everything about that week rhymes with 1936. The victims were old, they were poor, they lived alone, on upper floors, in neighborhoods with little tree cover, behind windows they kept closed because they were afraid of crime. Many were found days later. The city's morgue overflowed and refrigerated trucks were brought in. The difference is that the city and the country drew conclusions. Chicago built a heat emergency plan. Other cities followed. The National Weather Service developed formal heat advisories, heat watches, and excessive heat warnings, with criteria tied to the heat index, which combines temperature and humidity into a number describing what the air actually does to a body. Cooling centers became standard. Cities began doing wellness checks on registered vulnerable residents. Utilities stopped disconnecting power for non-payment during declared heat emergencies. The counting changed too. Excess mortality analysis, the method that produced the number 739 rather than a much smaller count of certificates, became the standard way public health agencies measure a heat wave. That is why modern heat tolls look so much larger than historical ones. They are not necessarily worse, they are counted honestly. There had been warnings before Chicago. In 1980, a heat wave across the central and southern United States killed somewhere between 1,200 and several thousand people, depending on the method. In St. Louis that July, 24 people died of heat stroke in a single day, and the governor of Missouri declared a state of emergency. The lessons did not stick. More recently, the Pacific Northwest experienced something that would have been called impossible by the standards of its own climate record. In late June of 2021, a heat dome of exactly the kind described in this report settled over Oregon, Washington, and British Columbia. Portland reached 116 degrees, Seattle reached 108. The village of Lytton, in British Columbia, reached 121 degrees, tying the highest reading ever taken in Canada, and burned to the ground the next day. Hundreds of people died across a region where almost nobody had air conditioning, because almost nobody had ever needed it. That event did something useful in a bleak way. It demonstrated that the mechanism from 1936 is not a historical artifact. A persistent ridge, dry ground, clear skies, and a population housed for a different climate will still produce mass casualties. In a country with satellites and supercomputers and 8 days of warning, the warnings in that case were issued. They were accurate. People died anyway, mostly indoors, mostly alone, mostly old. Which brings the account back to the point it started from. The technology that matters is not the thermometer, it is the neighbour who knocks on the door. Here is what is known. In the summer of 1936, a ridge of high pressure settled over the middle of North America and held its position for most of 2 months. Beneath it, ground that 3 years of drought and 2 decades of ploughing had stripped bare heated the air above it without restraint. Temperatures reached 121 degrees in North Dakota and in Kansas. 13 states still hold their all-time high temperature records from that summer. July of that year remains, by the narrowest of margins, the warmest month ever recorded in the contiguous United States. The Department of Commerce recorded 4,678 deaths from excessive heat in the United States that year, against 728 the year before. The commonly cited figure is about 5,000. Canada lost roughly 1,000 more. No American heatwave in the historical record has a higher toll. Here is what is not known. The true number of dead is not known, and never will be. The counting methods of the day recorded the obvious cases and missed the heart attacks, the strokes, and the failing kidneys that heat pushed over the edge. Modern methods would find more. How many more is a matter of estimate. Why the ridge held for so long is not fully settled either. The role of the degraded land surface is well supported by climate models and widely accepted. It has never been measured directly because the measurements were not being taken. Here is what carries forward. The place with the highest temperature is rarely the place with the most deaths. Heat kills in cities, indoors, at night, among the old, the poor, and the sick. It kills on the 4th day rather than the 1st. It kills quietly enough that it can be missed entirely, and it leaves nothing behind for anyone to photograph. The advice that follows from that has not changed and does not require any technology. Drink water before you are thirsty. Find a few hours of cooler air in the middle of the day, wherever they can be found. Rest during the hottest hours. Never leave a person or an animal in a parked car, and check on the elderly people you know, twice a day, in person, because they will not call you. What to watch for is the pattern rather than the number. When a ridge of high pressure settles over dry ground, and the overnight temperatures stop falling, that is the signal. Not the afternoon high, which the newspapers will print. The night that never cools, which they will not. The ground remembers. 90 years on, the shelter belts still stand across the plains, and the state records still stand beside them, and the two are part of the same story about what happens when the sky and the land agree on something. We will keep watching the next one.